All right. During lunch, thank you very much, underneath your tables next to the power supply, they dropped several yoga mats. So everybody up, dig out your yoga mat. Oh, wait, wrong forum. All right, it is the end of the day. My brain shuts down usually about 3 in the afternoon, so with a little luck, we'll make this quick. This afternoon, we're going to talk about reflections on mirroring with DPDK. This is something that we put together at the beginning of the fall, and just wanted to look back on what we did and some of the observations that we made in terms of where we think mirroring needs to go in terms of DPDK. One of the things that I don't have to preach to the choir about is debugging is hard. Debugging when a guest is an SR-IOV guest is hard, especially when we drop the kernel drivers, and we put in a DPDK driver. It gets harder when we have set up where we want to introduce some redundancy, 2 top-of-rack switches, some MLAG type things, which is the typical time that we usually get a call from somebody that's tried to do this to help them figure out why things aren't working. First question, though, is why do we want to drop the kernel drivers and use the DPDK driver? Our perspective is that we want to use something called VFD, Virtual Function Daemon. And I'm not going to go into what VFD is. In Dublin, my colleague Alex Zelianak presented VFD, and if you want to talk about it later, I'm more than happy to. But it's basically what we call a network hypervisor. It implements some policy. It is a DPDK application, but it does not process packets. It also is providing configuration on the NIC, both the PF and the VF, that aren't available from the kernel drivers, such as allowing the VF to change the MAC. So one of our typical guest problems is that we spin up a guest and all of a sudden we don't get any traffic, or we get some sporadic traffic. And as network professionals, we know that there are all kinds of possible causes for that. VLAN tags are wrong. The VF is configured incorrectly. Something at top of rack switch is wrong. There's no traffic arriving at all. And so in the normal world, we would just flip on tcpdump, and we would at least see something. We would see no traffic. We would see corrupted packets, or we would see VLAN headers that are wrong. But when we pull that kernel driver out of the mix, we can't do tcpdump anymore. We lose our tools. So we flip on tcpdump. Yep, we do. One of the things that we put into VFD at the end of the summer, the early fall, was mirroring. And what that allows us to do is when we have some of these debugging problems, we can use VFD to set up a mirror on the NIC, cause it to mirror traffic to another guest, and then we can run tcpdump in that other guest. So this picture here shows us receiving traffic on the second NIC, the bottom NIC, that's intended for the green guest, but through mirroring, we also are able to see that in the debug guest. It's also possible for us to attach a different driver to the VF and actually not have to spin up that second guest and be able to run tcpdump on that VF on the native, on the bare metal. So, was it easy to do? Actually, yeah, it was. It was very easy to do because we were able to take advantage of everything that was provided to us in the DPDK environment. We didn't have to write any NIC-specific code, which means that for any NIC that supports the mirroring, it works just fine. We can possibly expand it to include some VLAN-based mirroring, which right now we've got it implemented such that it's an all-or-nothing deal. And we can also enable this without any traffic disruption, which is important when we're doing some debugging in an environment that is processing production data. The bad things, though. We can only mirror traffic onto the same PF. We can only do it if we engage the loopback feature of the NIC, which our security department sees as a security issue in some cases. There's some inconsistencies between some of the NICs. I tested a couple myself. I've got somebody that works with me that does more of our testing, but I noticed a few things that seemed a little bit different. I haven't stressed them out quite yet, so I can't say specifics because I don't want to point fingers and be wrong. And then inbound mirroring is applied only after the VLAN filtering, and this is specifically to the Niantic-based NICs. But that can be a problem only from the perspective that I might have some inbound traffic that's being dropped because the NIC isn't passing it along because the VLAN header is wrong. So there are cases where we might miss some things. Mirroring in our environment, which is a telco environment, is for more than just local debugging as well. Some of our telco-oriented applications like to collect data from around the network, have it all mirrored to what they call a probe device, and then they can do things like put together a stepladder diagram that gives a really nice picture of the session setup of a phone call. Those things aren't possible unless you can direct the traffic off of the physical host where that traffic arrived and collect it someplace else. So in the little diagram here, we have 3 sources for the traffic that we'd like to mirror. This is all collected by a probe somewhere in the network. A lot of times these probes want traffic to be encapsulated. And today, about the only thing we can do is let that traffic come onto the box, be mirrored to a guest that's attached to the same VF, encapsulate it, turn it back around, and send it back to the probe. So we've got 2 extra hits on the PCI bus at least. Not a good situation. So one of the things that we're thinking in terms of future work, and this is something that we have not done anything about other than think about it, one of the things that we want to throw out into the DPDK community as food for thought is imagine. What if we were to extend RTE flow to not be in the path of the packet per se, as you might do in a typical packet processing application, but what if you took the interface that was there that does things like 5-tuple matching and have it configure a NIC that can then take that packet that comes in, match it based on whatever your criteria is, encapsulate it, because some of these NICs are getting to that point of view or that capability, and then the NIC, it turns it right back around and sends it back out on the wire. So now you get these probes fed with the data that you need. It's encapsulated how they need it, and you've not turned it round up into the system. You've not had to have a VM or some other process that's listening and no double traffic or triple traffic on your PCI bus. Some of these NICs support them, so let's maybe use it. Short talk to end the day, how's that? But not before I go on to thank the people that have supported us with VFD. We've got contributors and what I call encouragers. It's easier to list the encouraging, applauding people than it is the detractors. Oh wait, did I say that? And so I guess now I can say, I did well, huh?
You did really well, yeah. Thank you for...
do we want to open it to questions, or
sure.
do we want to push on?
I think we've got a couple minutes for questions, sure.
I like that.
Okay. Great. Thank you very much, Scott.
Thank you.